All right, so this is Video Workplace 20, section 3.2. We're talking about surface area of cones, and I'm telling you, when we talk about cones, it is, I just think of this movie clip when I talk about cones. So here it is for you.
You hit two cones. Those could have been people. Those could have been guests at her wedding. They were cones.
I don't know why. I don't know why that's so great. They were cones. So these are cones. These are cones. Surface area of cones. Are you following me here?
Yes.
You good? They were cones. Okay.
I don't get the joke.
They were cones. No, I said you following me here. That's what I said.
Oh, I thought you said, are you following?
No, I didn't call Sam Eric. No. Surface area of cones. Now, this one's strange. This one is, I will give you this. It's strange. The net for this is strange, too. Circular bottom. Okay? Do you know how you draw the net for a cone? It actually, if you were to actually cut this, if you were to actually cut, no, two triangles, that's a good guess. But if you actually cut this and wrap it, unwrap it, this point would stay, but this would kind of fold out. And this would fold out as well. And the edges, you cut a straight line here, the edges would kind of look like this. So the net, strangely enough, watch this, kind of looks like this. This is what it looks like. And you have a rounded, it looks like a lamp. That looks like a lamp, doesn't it? It looks like a lamp. Like, you know, you got a little chain here and you pull the lamp. Click, click. Hey, light's on. You know what I'm talking about? So it looks like a lamp. Okay, that's the net for a cone. Now, the circle's easy, right? Pi r squared. Got it. No problem. The surface area for the wraparound part, this is not quite a triangle. Look at it. It's not a triangle. You've got all of this that's extra. Okay, that could be viewed as a triangle, but what is that length? Well, we don't really know. I guess that could be almost the circumference, but it's not quite. This would be the circumference here, really, right? Because that's the wraparound part. So there's a special area for this, and it is the area for this part right here is pi times r times s, which is the slant height. So here is s, okay? The slant height, and I'll just kind of clean this diagram up a bit. The slant height goes from the edge of the circle to the point, right? It's the slant height. And notice that the slant height, the radius, and the height of the cone all make a nice right triangle. So h, r, and s are all related through Pythagoras' theorem. And that is exciting. I don't know if you knew that. That is very exciting because that just makes things really simple for us to solve for. If we ever wanted to solve for s, let's say. Let's say we're given the height of a cone and you're given the diameter of the cone, but you're not given s. And you're thinking, I need s to find the surface area. Well, if you're given the height and you're given the diameter, you can divide that by 2 to get the radius. Then you can use Pythagorean theorem to find s. It's h squared plus r squared equals s squared, and then you could find it. And once you find s, you could find the surface area. All right? So that's the surface area of a cone. The cones. The cones. See, look at. See? Look at this. Pythagoras. You see Pythagoras? Awesome. Okay? Pythagoras' theorem, the Pythagorean theorem, you can use that. So if we did one question here, surface area of a cone, find the total surface area of a cone with a radius of 16 inches. So I'm going to draw a cone. How do you draw a cone? Well, just kind of like a half oval again, a half oval. And then put a point right up in the middle there, right up directly up from the middle, and then just draw straight lines from there, from the edge to the point. Okay? And then if you want to get real fancy, you could draw a dotted line with another sort of half oval shape like that. And then that's pretty pro right there. Okay? Then you've got a real cone there. And that represents the edge that you can't see because it's on the back side of the object. So the total surface area of the cone, radius 16, beauty. Let's put that on there. Here we go. That's a big R is 16 right there. Radius, 16 inches. A height of 20 inches. We've got the same units. That's beauty. Height is right here, 20. So here's a case where I'm not given S. Oh, that's sad, isn't it? Everyone go, oh, we don't have S. But now don't be sad because Pythagoras tells us this is easy. So 20 squared plus 16 squared equals S squared. That's a right angle right there. Look at that. Okay? So what's 20 squared? 400. What's 16 squared? 256. 256 equals s squared. What's 400 plus 256? 656. What's s? Wow, excuse me. On, clear. Excuse me again. The square root of 6, 5, 6. 25.6. 25.6. So that's what s is. Now don't get too excited here. Whoops. I'm sorry. This is s squared is 656. So s is what a mess. Okay. Inches. So we're not done because we need to use s now to find the area. So the surface area of the cone, surface area of the cone is pi r squared for the base plus pi r times, help me, who's paying attention? Plus pi r what? S, thank you. Okay, was somebody paying attention? Maybe. All right, so what's pi r squared? Well, that's pi times what's r? 16 squared plus pi times what's r? 16. What's s? 25.6. Okay, you jump on your calculator, you type that in, and you should get an answer. All right, so 2091 should be your answer there when you do that on your calculator. 2091, and yeah, there you go. We got your little diagram. Did Pythagoras. That's not very neat. Sorry. Here it is, pretty neat. Okay, solve for s, which we did. Surface area is the circle at the bottom plus pi r s. That's the wraparound part of the cone. Fill everything in. 2091 square inches. Good to go? Any questions about the surface area of a cone? The cones.
Subscribe. Like, comment, go to MrMathWell.com.
Please.